Chapter 7 of Introstats 5th edition talks about linear regression, and this really builds from what we'd seen before in Chapter 6 in terms of scatter plots and correlations. Here, the example that motivates things is the relationship between the protein and the fat in various Burger King sandwiches. So least squares is the idea of a line of best fit, which is defined mathematically here, and the important idea of a residual from such a model and how we kind of put that together. And this is going to be fundamental what we'll be doing in terms of modeling. We have the definition here of the slope and the intercept. These b's, or betas, as I will tend to call them, will be used a little bit later to kind of be thinking about other models. The idea of a linear model is not new to you. It's this kind of thing that's included in the high school curriculum. And we're going to be letting R do the heavy lifting to actually find the values for these as we proceed through this semester. So there's several examples here of thinking about what the relationships are, what the assumptions are, and how to actually go ahead and express these. There's an important concept here, the idea of regression to the mean. And that's something we'll come back to, and it's worth a careful read in this chapter. Whenever we fit a model, we want to be thinking about assessing that model. And section 7.5 talks about examining residuals from a model, and to give some sense of how those give us some idea of whether or not our model is appropriate or not. There's an important idea called the residual standard deviation, which we will be seeing a little bit later on, which gives us kind of an average error for the model. And also another measure we'll be using throughout the course, R squared, also known as the coefficient of determination. This is the variability accounted for by the model. So there's no kind of judgment about what the value is of R squared. It really depends. But there are these important conditions. We've seen them before: the quantitative variables condition, the straight enough condition, and something called the does the plot thicken condition, which is very useful to be exploring. It's important that we don't have kind of changes in variability. So there are some nice examples in the rest of the section. As always, there's the what can go wrong, good things happening to bad people in various ways, and then the chapter review as usual. There's also a nice little example here about tech support and looking at these models in software. And again, that's part of what we do in the IS5 and R companion materials. Here we read in the Burger King data set, clean up the variable names, generate a scatter plot. We fit a model using something called the LM function. And that LM function given here takes fat as the outcome and protein as the predictor. We can go ahead and make something called a function that will allow us to query that for particular values. So, for example, what's the predicted value if we had a protein value of 31? That's equal to 36.7. What are the coefficients of this model? Well, the intercept is 8.4, and then the slope, the predicted increase of protein increases by 1 unit, is 0.91. If we say burger fun of 0, it actually gives us an estimate. Plugging in exactly when the protein is 0, we get back our intercept. That's the definition of the intercept, is the value when x, or the predictor, is 0. We get a slope by just calculating the difference for any two particular values. That gives us this value of 0.9. There's a function called mSummary in Mosaic, which will go ahead and give us something that looks a lot like that example in the textbook. These estimates, and what we'll see later on, things called standard error, t-values and p-values. Ignore those for right now, but let's focus on a couple of things. We have our root mean squared error, this residual standard error here of 10.6. It tells us that's the average error we have in our estimation, and an R squared of 0.57. We've explained about 57% of the variability. We can go ahead in the same way we added the smoother. We can add a linear model to a straight line to a plot. We've done this here by using GF point and the GF underscore LN.